Okay, for number one, we're simplifying each expression. We have 2 minus 3 over negative 4 plus 1. You have to take 2 and subtract 3 from it. 2 minus 3 is negative 1 over negative 4 plus 1 is negative. You take 1 away from 4 and you keep the common sign, keep the negative sign, I should say. Leaves you with negative 3. What you have here is negative 1 divided by negative 3, which is a negative divided by negative, which is a positive 1/3 as your simplified answer. For number two, you have negative 2 minus 1. These are the same sign, negative and negative, so add them up. 2 plus 1 is 3, and keep that common sign negative. 2 plus a negative 3 is the same thing as 2 minus 3. Either way, it's opposite signs since this one's positive and 3 is negative. So subtracting 3 minus 2 and you get 1, and you keep that the one that's farther away from 0, which is negative 3, so keep it negative. So what you have here is negative 3 divided by negative 1, or a negative divided by negative, which is going to be a positive 3 over 1, which is simply 3. We're evaluating x equals negative 1, 0, and 2. So we're actually making an input-output chart with these. You can go ahead and write the whole thing out, or you can simply make a quick input-output table like this, x and y, or more specific, I guess we could do x and f of x. Remember, that's the same thing as x and y. So when we plug in the first one, we have negative 1. 3 times negative 1 is negative 3, and negative 3 minus 7 is negative 10. The second one, it says plug in 0, so 3 times 0, or anything times 0, is going to be 0, and 0 minus 7 is negative 7. And then the last one, 3 times 2 is 6, and then 6 minus 7, we put 2 here, 6 minus 7 is negative 1. So that's your evaluating. Again, we can do the same thing for this next one. Looks like we have slightly bigger numbers, but it's not going to really change what we're doing. We have x and we have f of x. Remember, x or y. The three values we're going to use, we'll use negative 1, 0, and 2. 32 times negative 1 is negative 32, and 205 plus, or 235 minus 32, plus a negative 32, or minus 32. Negative 1 times, again, sorry, interrupted, 32 times negative 1 is negative 32, and negative 32 plus 205, or 205 minus 32 is going to be 173. When you multiply anything times 0, like 32 times 0 is going to be 0, so 205 plus 0 is simply 205. And then 32 times 2 is going to be 64, and 64 plus 205 is 269. So we have slightly bigger numbers, but not really any harder than number 3. Okay, today we're looking at lesson 5.1. It's on page 273. We're writing linear equations in slope-intercept form. We have a couple of goals. Our first one is to use the slope-intercept form to write an equation of a line. And the second one is to model real-life situations with a linear function. First thing we have is the definition of slope-intercept form. We have gone over this already. Y equals mx plus b. It says the slope-intercept form of the equation is y equals mx plus b, where m is the slope and b is the y-intercept. Remember, we said that there are 4 things inside of this equation. There's a y, there's an m, there's an x, and there's a b, or there are 4 variables in this equation. We'll go through all of them real quick. The first one, y, its value is, when you're looking in an ordered pair, there's an x comma y, its value is the y in the ordered pair. The m is the next thing that's in the equation. The next, that was the first variable. The second variable is m, and we've identified the m as the slope. Remember, slope is the same thing as rise over run, which is the same thing as the change of y, because it's up and down, over the change of x, because that's side to side, which is the same thing as a visual, up and down over right and left. Uh, the third variable is x. Just like the y value, you have an ordered pair x comma y. Instead of being the y value, it's the x value. And what I mean by those two, the x and the y values, if you pick a point that's on a line, it is it in that x and y value, that's what you're going to use. And then a final variable in that equation is the b, which we've identified as the y-intercept, which when you look at a picture of an equation, the y-intercept is where it actually crosses through. Since this is your y-axis here, it's where it crosses through the y-axis. That's the y-intercept there. Your slope is your directions when you're graphing, and your y-intercept is where you start. It's your starting point. That's when you're actually graphing an equation. Today we're actually going to take an equation that's graphed, and we're going to write the equation from it. Example number 1 says write an equation of a line. Write an equation of a line whose slope is 4, or its m is 4, and whose y-intercept is b is -3. So you have m equals 4 and b equals -3. Now we know the equation, our slope-intercept form is y equals mx plus b. So all we need to do is we're going to leave we're going to leave y and we're going to leave x, but we're going to plug in m and we're going to plug in b. So in place of m, you can see it here, right here. In place of m, we plugged in 4, and in place of b, plugged in -3. Remember, plus a -3 is the same thing as -3, so your equation would be y equals 4x minus 3. Y equals 4x minus 3. Okay, you can take another example where you're given an m value of 1/2 and a b value of -2. And you could write an equation likewise. Again, it's going to be y equals mx plus b. So what you want to do is you want to leave the equal sign alone, and you want to leave the x sign alone, and then we're going to plug in something, and you want to leave the y alone. We're going to plug in something in place of the slope, and we're going to plug in something in place of the y-intercept. So we have our values. We have m's value is 1/2, so in place of m, we're just going to plug in 1/2. And then we have b's value, -2. So in place of b, it's plus b, and it's plus a -2, which is the same thing as -2. So the equation in this case would be y equals 1/2 x minus 2. Your first checkpoint says write an equation of a line in slope-intercept form where you have a slope of 3 and a y-intercept of 7. So m is 3 and b is 7. Y equals mx plus b. So in place of, we'll leave y, we'll leave equals, and we'll leave x. In place of m, you plug in 3. So 3x, and in place of b, you have a positive 7, so plus 7, y equals 3x plus 7. And then the last one for that checkpoint says the slope is -5, so m equals -5, and your y-intercept is -1, so b is -1. Again, y equals mx plus b. Start off, leave y, leave equals, and leave x, and then plug in something in place of m, and then plug in something in place of b. We have an m of -5, so y equals -5x, and we have plus b plus a -1, which is the same thing as -1, so y equals -5x minus 1. Example number 2 says write an equation of a line from a graph. The line intersects at y-axis at 0, -2. So what you're going to do is you want to look for where it crosses through your y-axis. It crosses through right there. Its y value is -2. You can see it here. It intersects at -2. So your y-intercept, or your b value, is -2. The line also passes through this point, -4, 0. So what we have there is we have a point x comma y that is -4 and 0. So we can use those values to find what we need. We need y equals mx plus b. We need to find the slope. In order to find the slope, it is equal to the rise over the run, or your slope formula is the change of y over the change of x. That's your slope formula. So we'll use the 2 points that we have, -4, 0, and that's, go ahead and erase this so we can see it a little bit better. Um, but negative 4, 0, and 0, negative 2. So, so you have x sub 1, y sub 1, and x sub 2, y sub 2. And then you're just plugging in your values for your formula. Negative 2 minus 0 on top, over 0 minus a negative 4. Remember, anytime you have minus a negative, it means plus a positive. So negative 2 minus 0, or anything minus or plus 0 is it's just going to be whatever it is. So negative 2. And 0 plus 4 is 4. Negative 2 divided by 4, 2 goes into both of them. It goes into negative 2, negative 1 time, and into 4 2 times. So m's value is negative 1 over 2. So you have b's value at negative 2, and m's value now we just discovered is negative 1/2. So now you have everything you need to write your equation, m's value and b's value. So y equals mx plus b. Um, you go ahead and write your equation. You leave it as y, leave it as equals, and leave it as x, and then you're just plugging in m and you're plugging in b. We have the values for m. We just found out it's negative 1/2. And we got a value for b. It's a negative 2 plus a negative 2 is the same thing as minus 2. So y equals 1/2 x minus 2. Then we have a couple of checkpoints. It says write an equation of the line shown in the graph. First thing, this is your y-axis here, so this is your y-intercept, this point right here. It is at negative 2, so quickly your b value is negative 2. Then we need to find another point where it passes through integers. This looks like a good point right here. It doesn't pass through the middle of any lines. It passes right through the intersection of both of those lines. And that value is 2, 2. So we have 2, 2 there, and this bottom one here we have 0, negative 2. Okay, so what you need to do is you need to label those points. X sub 1, y sub 1, x sub 2, y sub 2. Or you could simply count. Since we have a small graph, we can count. Start at the lefternmost one, go up 1, 2, 3, 4. So we went up 4, that's positive. And to the right, 1, 2. To the right, 2, that's positive 2. 4 divided by 2 is 2. So your m value is going to be 2. So now that you have m and you have b, y equals mx plus b, leave y, leave equals, and leave x, and then just plug in something in place of m and plug in something in place of b. We have m's value as positive 2, so y equals 2x, and we have b's value at negative 2, so plus a negative 2 is the same thing as minus 2. Y equals 2x minus 2. And then the last one, this is your y-intercept here. Its value, b's value is negative 1. Another point that's it's going through integers, or where it's not going through the middle of any lines, would be that one right there. That value is negative 3, 0, and 0, negative 1 is your y-intercept. Again, you can use your slope formula, and you call this x sub 1, y sub 1, and x sub 2, y sub 2. Or you can simply count when you're using smaller graphs. It's usually the easier way to go. So start at the lefternmost one. You have to go down one time. So that's minus 1 since we went down. And we have to go to the right 1, 2, 3 times. So since we went to the right, it's positive 3. So your slope value is negative 1 over 3. So y equals mx plus b. Again, you're going to plug in your values that you have. You have leave y, leave equals, and leave x. And all you do is plug in m's value. You have m's value right here, negative 1/3. And b's value, you have it right here. Plus a negative 1 is the same thing as minus 1. So y equals negative 1/3 x minus 1.